Today we're going to look at the midpoint and distance formulas, and we're going to develop them. So rather than using them, we're just looking at where they come from. So let's start with 2 points. We could have a point here at, what is that, 3, 1, 2, 3, 4, 5, 6, 7, 8. And we could have a point somewhere down here at, is that 1, 2, 3, 4, 5, 6, 7, 8, 9, 3. So there's 2 points, and we want to find the distance from one point to the other. And we also want to find the midpoint of that line. So somewhere in the middle there, we have this point here that we want to find. And that's not very well placed. So that's going to be our goal. We're going to come back to having specific values. First, we want to look at what if we had some generic values, x and y. So if we replace these with x1, should probably switch that back to standard. x1 and y1 and x2 and y2. So these represent generic points where x1 and x2 are different values. x1 and y1 are just the coordinates of that point. x2 and y2 are the coordinates of the second point there. So to find the distance, we could create a right triangle like so, and use the Pythagorean theorem to find the distance. But to do that, we would need to know the sides. So, since I don't want to use exact points, I can't count. But we know that the distance from here to here has to be the difference between this y value and this y value. So if I subtract them, y2 minus y1 will give me that distance, in absolute value at least. And the x distance is going to be the same thing there. This distance here has to be x1 minus x2, or x2 minus x1. We want to stay with the same order of our values. So those will be the distances there. So using the Pythagorean theorem, our hypotenuse will be equal to the y value squared plus the x value squared, all under the square root. So we call our hypotenuse d, the distance between the points. The distance must be equal to the square root of the height squared plus the length squared. That's all under the square root. So that's how we develop the distance formula. So going back up here, we could find this distance without doing any of that work, just using the formula. The distance will be equal to the square root of, I'm going to plug in 8 minus 3 squared. Those are the y values. So that's from this 8 and this 3. Then we're going to plug in 3 minus 9 squared. Notice, even though 9 is bigger than 3, I stuck with this value here because I put 8 first here, and that comes from up here. So you have to stick with x1 and y1 going first. But it won't really change our ultimate answer thanks to the squares. 8 minus 3 is 5. 5 squared is 25. 3 minus 9 is negative 4. Negative 4 squared is positive 16. So we put that together. 5 plus 6 is 9. 3, not 9, that's 4, that's 5. 5 plus 6 is 11. 1 plus 2 is 3, plus 1 is 4. So it's going to be 41 square root. And we can estimate that, or we can leave it as a square root. For now, I'm going to leave it as a square root. So that's how we find the distance between 2 points. to find the midpoint is actually a little bit easier. So again, we want to think about our values here. So finding the middle of the line from this point to this point is decently easy. The x value of this point must be the same as the x value of this point, because it's just a vertical line between them. And then the x value here we already know. So nothing too difficult there. If we average the x values, we'll get a number here in the middle. So we're going to take x2 plus x1 and divide it by 2, and that will give us the middle number of this bottom line. We'll do the same thing here with y. The y value, well, we know the y value here is y1. The y value here has to be the same as the y value here because it's a horizontal line between them. So y2 plus y1 all over 2. So our midpoint formula is just the point that is at the average of the two x values. And the average of the two y values. So there's our formula for the midpoint, and that will tell us the midpoint because that will give us that point right there. So coming back up here to this problem, if we wanted to find the midpoint, all we have to do is take our x values, 3 and 9, divide them by 2, and our y values, 8 and 3, and divide them by 2. 3 plus 9 is 12. 12 divided by 2 is 6. 8 plus 3, and here we have an odd number, which is a little less convenient, but it still works. So 8 plus 3 is 11, and 11 halves. We can leave it as an improper fraction, or we can put this as 5 and 1/2 or 5.5. So I prefer improper fractions or decimals to mixed numbers, so we're going to leave it like that. But either of those would be acceptable depending on your application. And that's it. That is the midpoint and the distance formula.